Hi everyone. Here's the lesson from yesterday that we tried to get to towards the end of the hour and didn't. This is the lesson on trapezoids, so it'll be the next page in your notes packet. And this video will be posted on my website as of this afternoon. So if you missed something during class, if you feel like, gosh, I missed a definition, I need to rewind or something like that, go check for it over the weekend. Okay, so trapezoids. Trapezoids are the newest quadrilateral we're talking about. You probably already have this definition written down someplace, but what you need to know about trapezoids is that they are a quadrilateral. This is the important part. It's a quadrilateral with at least one pair of parallel sides. And the at least part is important because the at least part is what tells you that a parallelogram could also be a trapezoid, because a parallelogram has two pairs of parallel sides. A trapezoid only has to have at least one. So a parallelogram is a type of trapezoid. And when you're looking at a trapezoid, those sides that are parallel are called your bases. So in this picture, if this were a trapezoid, pretend I highlighted the actual side, and this would be the bases because those are parallel. Okay, so for our definition for base, let's write in the parallel sides. So anytime I say the base of the trapezoid, and I know that's confusing because usually when you think of base, you think like the bottom or the one side at the bottom. Trapezoids have two bases. We always call the bases the two sides that are parallel. Okay, so those two are your bases. Okay, isosceles trapezoid is a little more specific. An isosceles trapezoid is a trapezoid where the non-base sides are congruent. So the sides that are not the bases are congruent to each other. And so again, if you look in the example down there in the lower left corner, you've got your bases here and here. Those are your parallel sides. But then notice that your other sides, this one and this one, are congruent to each other. That's what makes it an isosceles trapezoid. If you've got one pair of sides that's parallel, these ones are parallel, and then another pair of sides that are congruent. Okay, so keep that straight, parallel and congruent. So take a look at this picture. You've got parallel lines here and here. And if I extend this DA, this picture should be looking familiar, because as always, those are parallel. And I want to know what types of angles are angle A and angle D. Think about that for a minute. Hopefully, you came up with same side interior angles. Okay? And same side interior angles are supplementary. Okay? They're on the same side of the transversal, so they're both on this side of the transversal, and they're in between the parallel lines, so same side interior. And we know same side interior angles are supplementary. So now we have the trapezoid angle theorem. And the trapezoid angle theorem says, in a trapezoid, consecutive angles between a pair of parallel sides are supplementary. So consecutive, this word consecutive, means right next to each other. These two are consecutive. And they are between the two parallel sides, so they have to be supplementary. And we could sort of tack on to the end of this. I mean, it's not part of the theorem, but if I were to prove this theorem, it's because, and you don't have to write this part down because you wrote it down sort of up above, but because they are SSIA, or same side interior angles with parallel lines. That's how you know they're supplementary, is because they must be same side interior angles. Okay, so again, supplementary is the key word here, that those angles are always going to be supplementary. Okay, so now think for a minute. If I give you a trapezoid, does it have a line of symmetry? And if I give you an isosceles trapezoid, does it have a line of symmetry? Well, just any old run-of-the-mill trapezoid does not necessarily have a line of symmetry. There's no place that I could drop that that would cut it exactly in half. Sorry, I was playing with my cursor. So a line here wouldn't work, a line here wouldn't work, because you don't have any sides that are necessarily congruent in a regular trapezoid. However, in an isosceles trapezoid, you should see that if I cut straight down the center here, because this side and this side are equal to each other, this side and this side are equal to each other, then there is a line of symmetry right down the center. So now let's make a theorem. So we know in an isosceles trapezoid, the perpendicular bisector of one base must be the perpendicular bisector of the other base, and then that line is your line of symmetry. I'll wait a second for you to write that down, and then we'll talk about what that means, because there's a lot of information packed into that sentence. Remember to abbreviate. Don't get excited, that wasn't your bell. Okay, so what that means for us is this blue line that's right down the center of the trapezoid, if it is a perpendicular bisector, meaning if this is a right angle here, and these two pieces are equal, actually I should use two lines because I already have one line on the side. If I know that that is true, okay, if I know this is true, then I also know that this is a right angle, and I know that these pieces have to be equal to each other. Okay, so that one line gives me a lot of information. And I know that blue line is a line of symmetry. And if it's a line of symmetry, I want you to think for a minute. If it's a line of symmetry, what do you know about angle C and D and angle A and B? If I folded it right on that blue line, what would happen with those angles? Okay, I'm waiting for you to answer me, and clearly you're not going to because, well, you're not here right now. But the important thing to take away from this is probably the most important thing in this entire lesson, is the isosceles trapezoid base angle theorem. And here's how we're going to write this out. We're going to say angles that share a base in an isosceles trapezoid are congruent. Okay? Angles that share a base in an isosceles trapezoid are congruent. So what that means is angle C is congruent to angle D because they're on the same base together, and angle A is congruent to angle B because they're on the same base together. Okay? So I have that these angles are congruent and these angles are congruent. And then remember what we just talked about was these angles are supplementary and these angles are supplementary. So that means that if I give you one angle in an isosceles trapezoid, you can figure out every other angle. So let's prove something. Oh, I'm sure you've missed proofs a lot. Let me find a good color. Okay. We are given that this shape is a trapezoid. We are given that this shape here is a trapezoid. And it tells me that AB is parallel to CD. So we know these two are parallel, and of course I'm going to mark my information right away. And then it just tells me that they've taken this segment AD and extended it to create point E. Okay, so the first thing I would say for my step 1 is ABCD. I'm going to try to write small enough. Is a trapezoid. And I should also include in there that AB is parallel to CD. Sorry, I didn't fit all of that in, but your justification, of course, think back to when we did proofs, is given. Okay? So then, it says angle 1 plus angle 2 is 180. That's right here. How do I know these two angles make 180? Think about that for a minute. Those two angles equal 180 because they make what's called a linear pair. Remember, if two angles are right next to each other on a line, they make a linear pair. So this is called, and I don't know if we ever talked about this as a theorem, but it is one. The linear pair theorem says if two angles are next to each other and they make a straight line, that the two angles must add up to 180. Okay. So now I know that angle 1 and angle 2 equal 180. What I really want to know is that angle 1 and angle D equal 180. So how can I get angle D into this? Well, look at angle 2 and look at angle D. And look at your parallel lines. What kind of angles are 2 and D? I know angle 2 is congruent to angle D because they are corresponding. And that was actually the corresponding angles postulate. Okay, corresponding angles postulate says corresponding angles have to be congruent. Okay, so now I know that angle 1 and 2 equal 180, and angle 2 is equal to angle D. So if angle 2 is equal to angle D, that means I can take angle D and put it in place of angle 2 right here. Because if these two are equal to each other, they're interchangeable. Okay, I can substitute one for the other. I'm not sure if we talked about this in a proof, and we're going to be doing more practice with proof in this chapter, so don't let this one freak you out. This is one example. But this is substitution, where I'm allowed to take one thing and plug it in for another one. Okay? And then if I know that the two angles add up to 180, I know that they must be supplementary because that's what supplementary means. So I can say angle 1 is supplementary to angle D. Because that's what supplementary means. Definition of supplementary angles is right here. Okay? If they add up to 180, then they must be supplementary. Okay, we'll practice with those some more. I'm sure you're very excited about practicing with those some more. Okay, it says AB is parallel to CD. Find as many other angle measurements as you can. So here are your parallel lines, this one and this one. And I know angle C is 118. Okay, so what else do I know? Well, I know these two are in between the parallel lines, so those two have to add up to 180. So I can do 180 minus 118, and let's see, that's going to be 62. Now here's the thing. As it's drawn and as it's given to me, it doesn't tell me that this is an isosceles trapezoid. So if I don't know that it's isosceles, I don't know anything about these angles right here. The way the question is worded right this moment, that's all I know. What I've just written down is all I know. If I threw in there that this was isosceles, this is just strictly hypothetical. If it was isosceles, remember you would have that symmetry line down the middle, and so then these angles would match with these angles, and I would know this was 118 and this was 62. But again, to be clear, the way the question was originally worded, the only angles you would know were these ones over here. Okay, if it doesn't say isosceles, you can't assume it's isosceles. But I just know you're going to see some like that later on, so I wanted to make sure I kind of covered it both ways. Okay, GHJK is an isosceles trapezoid with bases GH and JK. That means that GH and JK are the parallel sides. Remember, if they're the bases, then they're the parallel ones. So this is parallel to this. Usually with trapezoids, you can tell by looking which ones are supposed to be parallel, but try not to make too many assumptions in geometry. It says HJ is 31.8 and angle H is 19. And notice that this time it does tell me that this is an isosceles trapezoid. Okay, so just like before, I'm going to find this angle J down here. I'm going to take the 19 and subtract from 180. So 180 minus 19 is 161. And since this is isosceles, there's my symmetry line, and everything over here on the left, sides, angles, everything, are going to match up with what's over here on the right. So now I know this is 19 degrees. I know this is 161 at angle K. And I also know that this side over here would be 31.8. That's everything I can tell. I don't know anything about the length of the bases. Okay, but in an isosceles trapezoid, I would know all of those things. Okay, both of your homework assignments should be listed on the top right corner of the board. Make sure you're working on those. Those are due on Monday, both of them. So 6-4 covered kites from yesterday. 6-5 is today's stuff on trapezoids. I will be available via email all weekend, so if you need some help, if you have some questions, please feel free to contact me. Have a great weekend.